Hi everyone, welcome back. We are moving on in Module 2. We are still in Topic 1. We are on Lesson 3. And we are starting with the introduction, which is page 193. Different but the same, determining equivalent ratios. So our learning goals: to use drawings to model and determine equivalent ratios, reason about tape diagrams to model and determine equivalent ratios, define and use rates and rate reasoning to solve ratio problems, use scaling up and scaling down to determine equivalent ratios, use double number lines to solve real-world problems involving ratios. I know a lot of you are already doing all of these things in Mathia, so if you're having any issues with that, hopefully after this lesson, that will be a little bit more clear for you. Terms: equivalent ratios, tape diagram, rate, proportion, scaling up, scaling down, and double number line. Quick start says review 1 to 2 minutes. We probably don't even need that long. It says circle the correct statement to complete each sentence. It takes 5 workers to paint 3 houses in a day. So that's just a statement of fact. 5 workers to paint 3 houses in a day. Number 1 says painting fewer houses with more workers will take. So does it take less time, an equal amount of time, or more time? So think about it for a minute. Pick something, circle it, and then do this one. Number 2, painting more houses in a shorter amount of time requires fewer workers, an equal amount, or more workers. So painting more houses in a shorter amount of time. Okay, I want you to pause and I want you to answer those. Okay, so hopefully you did that. So number 1, painting fewer houses with more workers will take, that's right, it takes less time. If you're painting less houses and you have more people, it's going to be less time. Painting more houses in a shorter amount of time requires more workers. Okay, awesome. Moving on. We are not going to do the getting started. I'm not a big fan of this page. I think it's just going to cause confusion. I don't like the way things are worded. So, moving on. Activity 1. So, use drawings to model equivalent ratios. So, habits of mind, model with mathematics, and use appropriate tools strategically. Using drawings to model equivalent ratios. Carrie and her friends are going hiking. Carrie invites her friends to meet at her house for a quick breakfast before heading out on their hike. She wants to offer yogurt to her friends. She knows that one yogurt pack has 4 yogurts that can feed 4 people. So you know how sometimes you see the yogurts in the store that there's like 4 little yogurt containers and they're kind of all joined together and like you snap them apart, right? They kind of look like that, right? And they're kind of like, they're almost kind of all joined together and you like snap one apart. So that's what we're talking about here, this type of yogurt. So it says draw a model to answer each question. What is the relationship between the yogurt pack and the number of people it will feed? So going back and rereading then what we were told, it says one yogurt pack has 4 yogurts that can feed 4 people. So what is the relationship so that we know then that one yogurt feeds one person? So a pack of 4 yogurts feeds how many? Right, 4 people. If Carrie invites 6 friends, how many yogurt packs? Oh, I'm sorry. So it says to draw a model. Really, our model is kind of this right here. So each yogurt, and we can kind of like draw that as our little thing. I can even just put a Y for yogurt. Each of those is the yogurt. If you don't want to draw the squares, I'm okay with a Y for yogurt. So if Carrie invites 6 friends, how many yogurt packs will she need? Well, we know that they come in 4 packs, right? So There's kind of two ways to answer this question. So they come in 4-packs. So there's one of the 4-packs. So that'll feed 4 friends. Another yogurt pack. She needs 2 of them out of the 4 to feed the other 2 friends, but you're not buying them by 1.5 packs. Like truly she needs. So she truly needs 1 1/2 packs. But you can't go to the store and rip two of them off and go up to the register and say, I only need 2, not the 4. So how many do you have to buy? You have to buy this group of 4 as well. So you have this yogurt pack and this yogurt pack. So she'll need to buy, needs to buy 2 packs. Okay, so now it says, if Carrie has 2 3/4 yogurt packs, how many friends can she feed? So now we're going to assume she's not buying this. Let's just assume she has this at home. So let's draw a model for 2 3/4 yogurt packs. Go ahead and do that. I want you to do that while I'm doing it as well. I'm not really going to try to show you what I'm drawing here. Okay, so hopefully your drawing matches mine. So here's 1 yogurt pack. Here's another 1 yogurt pack. And then here's 1, 2, 3. We're going to assume someone already pulled that one off and ate it. So there's 3 out of 4 for a total of 2 3/4. So how many friends can that feed? Knowing 1 yogurt feeds 1 person. So if 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it feeds 11 friends. Okay, this one has 4. This one has 4. This one has 3 yogurts for a total of 11. Okay, moving on. Flipping over to page 196. Finishing up activity 1 here. It says let's consider a different variety pack. So this is page 196. If in one yogurt variety pack, 2 out of every 5 are blueberry. Okay, so if 2 blueberry, and then that looks like strawberry. There's strawberries on it. So it says draw a model to answer each question. How many yogurts are blueberry yogurts when there are a total of 25? So we're doing a part to whole here. So for each one, I'm going to use B for blueberry, and S for strawberry, strawberry, strawberry. So all together, that's 5. We need a total of 25. So that has a group of 5. Then I'll need another group of 5, 5, 10, 15, 20, 25. So then I just need to draw out each yogurt pack. Each one has 2 blueberry and 3 strawberry. 5, 10, 15, 20, 25. So that's the 25 total. So how many are blueberry? 2, 4, 6, 8, 10. So there are 10 blueberry. So then it says how many yogurts are blueberry when there's a total of 35 yogurts. So we just need to extend this 10 more. We had 25, now we need 35. So we can redraw the whole thing, or I can just say, okay, well, if I just added 2 more, because there's another 5, another 5. 5, 10, 15, 20, 25, 30, 35. So blueberry, 2, 4, 6, 8, 10, 12, 14. So 14 are blueberry. Okay, so we can go back and figure this out a little bit differently as well. And I want to take a second just to do that. So if we had 2 blueberry for every 3, now let's say 5 total, a part to whole, 5 total. And then we are being asked, I'm going to do this one here first, for a total of 25. How do we go from 5 to 25? Right, we are multiplying by 5. Adding 20 doesn't make sense because we're not going to add 20 to this. We're not going to have 22 blueberry when there's 25 total. That just doesn't make sense. And we just showed that it was 10. So if we multiply by 5 here, we multiply by 5 here, and we get the 10. Does the same thing work here for this one? I'm going to switch to a different color just to make it easier to read. So when we want the 35, we have 2 blueberry for 5 total, and we want 35 total. How do you go from 5 to 35? Times 7. So 2 times 7 gives us 14, which is what we had. So now it says, how many total yogurts are there when 8 yogurts are blueberry? Okay, so we know our original ratio is 2 blueberry for 5 total. So now it's telling us when there's 8 blueberry. So we have blueberry on the top, so we need to keep blueberry on the top. So 8 blueberry, and they want to know how many total. So how many total? Well, how do we go from 2 to 8? We multiply by 4. When you do the top, you have to do the bottom, so we keep an equivalent ratio. So 5 times 4 gives us, right, so 20. So there would be 20 total yogurts. You could draw it out with a model as well. So if 8 are blueberry, so there's 2, 4, 6 blueberry, 8 blueberry. So there's one group, 5, 10, 15, 20 total. Okay, so it works both ways. It says, as you solved these problems, you determined equivalent ratios. Equivalent ratios are ratios that represent the same part to part or part to whole relationship. Basically, they're equivalent ratios. You guys can think of them in terms of equivalent fractions. Remember, it's really only a fraction when it's a part to a whole. Otherwise, we say it's in fractional form. Okay, we'll see you on the next video for activity 2.